Hello everyone. Today we'll be discussing about the full wave rectifier. We'll be looking into the types of full wave rectifier uh, and the circuit diagram, the waveform, the construction, the working, the efficiency, the advantages, disadvantages, and finally the application of a full wave rectifier. So the definition. A full wave rectifier is defined as a rectifier that converts the complete cycle of an alternating current into a pulsating direct current. So we have two types of a full wave rectifier. So here we have center tap full wave rectifier as well as a full wave bridge rectifier. But we'll only be discussing about the center tap full wave rectifier. So center tap full wave rectifier. So the major components of this circuit is two diodes, a center tapped transformer, and a load resistance. So here we have the circuit diagram of a full wave rectifier. So as we can see, it consists of two diodes D1 and D2. It consists of a load resistor as well as a step down transformer. So now looking into the construction of a full wave rectifier. So full wave rectifier circuit, it consists of a step down transformer and two diodes that are connected and center tapped. So the output voltage is obtained across the connected load resistor. Now let's look into the working of a full wave rectifier. The input AC supplied to the full wave rectifier is very high. So basically a step down transformer is used to convert this high voltage AC into a low voltage alternating current. So the anode and the center tap diode is connected to the transformer's secondary winding and connected to the load resistor. So during the positive half cycle of the alternating current, the top half of the secondary winding becomes positive while the second half of the secondary winding becomes negative. So now let's look into what happens during the positive half cycle. So during the positive half cycle, the diode D1 is forward biased as it is connected to the top of the secondary winding of the transformer, while diode D2 is reverse biased as it is connected to the bottom of the secondary winding. So due to this, the diode D1 will conduct acting as a short circuit, whereas the D2 will conduct acting as an open circuit. So during the negative half cycle, the diode D1 is reverse biased and the diode D2 is forward biased because the top half of the secondary circuit becomes negative and the bottom half of the circuit becomes positive. Thus, in a full wave rectifier, DC voltage is obtained for both positive and negative half cycles. So this is the output waveform as well as the input waveform of a full wave rectifier. So as we can see, the input of a full wave rectifier is a sinusoidal waveform, and in the output, we actually the input is an alternating waveform, and the output is the direct waveform. Now looking into the efficiency of a full wave rectifier. So the rectifier efficiency is used, it is a parameter. So it is used as a parameter to determine the efficiency of the rectifier to convert AC into DC. So it is the ratio of DC output power to the AC input power. So the rectifier efficiency of a full wave rectifier is 81.2%. Now looking to into the advantages of a full wave rectifier, the ripple factor in full wave rectifier is low, hence a simple filter is required. So the value of ripple factor in full wave rectifier is 0.482, while in half wave rectifier it is only about 1.21. The output voltage and the output power obtained in full wave rectifiers are higher than that obtained in a half wave rectifier. So now looking into the disadvantages of a full wave rectifier. So it is more complicated than the half wave rectifier, and the PIV rating of the diode is higher. Higher PIV diodes are larger in size and too much costlier. So the cost of the center tap transformer is high. Uh, Now coming to the application of a full wave rectifier. So in electric wielding to supply steady DC voltage in a polarized way, the circuit is preferred. As the efficiency of rectification is high in this rectifier circuit, it is used in various appliances as a part of the power supply unit. It has the capability of converting high AC voltage to low DC value. In case of powering up of the devices like motors and LED devices, these are used. So we have discussed about the working, construction, efficiency, advantages, disadvantages, and applications of a full wave rectifier circuit. So before I conclude this video, I would like to speak about full wave rectifier with a capacitor filter. So as you can see in this circuit diagram, there is a new capacitor being introduced. So the purpose of this capacitor is that, as you can notice over here, the output DC waveform is smoothened. So now coming to this, even though the full wave rectifier rectified both positive and negative half cycles, the DC signal obtained at the output still contains some ripples. So to reduce these ripples at the output, we use a filter. So the filter is an electronic device that converts the pulsating direct current into a pure direct current. The filter is made up of a combination of electronic components such as resistors, capacitors, and inductors. The property of an inductor is that it allows the DC components alone and blocks the AC components. So the filter made up of a capacitor and a resistor is known as a capacitor filter and is placed across the load resistor RL as shown in the figure previously. With this, I would like to conclude today's video. Thank you.